We are looking at the integral from 1 to 2 of e to the x dx. We aren't going to estimate it using t sub 10 or m sub 10. That's part of the problem in the textbook, but we've already seen how to do that. I'm really focused on the errors, and that's what we're going to do. Estimate the errors for t sub 10 and m sub 10, and then we're going to find out what n gives error for the trapezoidal rule of less than 1/10,000th, and likewise the midpoint rule. Since our integrand is e to the 1 over x, with the differential dx, we know that f of x is equal to e to the 1 over x. And as a refresher, e sub m in magnitude, or in absolute value, is less than or equal to k times the quantity of b minus a cubed over 24n squared. And the absolute value of e sub t is less than or equal to k times the quantity of b minus a cubed over 12n squared. Now I'm sure you have a handle on b minus a and n, right? And in this case, n is 10, right? So there it is. Right now, we need to focus on finding k. K, remember, is a value such that the second derivative of f is less than k for x in the interval, in this case, from 1 to 2. Folks, that means we need the second derivative of f. Just for practice, I want you to pause the video and go ahead and find f double prime for e to the 1 over x. I did a bunch of work that I'll talk about in a minute, but I just realized I made an error when I wrote something down a minute ago. K is a number where the second derivative of f in absolute value is less than or equal to k. F prime is going to use the chain rule, so we've got the negative of e to the 1 over x squared, because the derivative of 1 over x is negative 1 over x squared. For f double prime, we got to use the quotient rule, so I pulled the negative out front here, and then u prime, we already did that, it's the same value, v is x squared, minus uv prime, so we have 1/2 e to the negative 1 over x squared e to the 1 over x times x squared minus e to the 1 over x times 2x all over x to the 4th. You'll notice that the negative distributes. The x squareds divide out in the first term of the numerator, and we have e to the 1 over x times the quantity of 1 plus 2x over x to the 4th. Now, k is a value that is bigger than the second derivative takes on over the entire interval, in this case from 1 to 2. But I don't know where the second derivative of f is going to be biggest in the interval from 1 to 2. In fact, it would be nice to know if f double prime was increasing or decreasing, because if it was increasing, then I would use the input value of 2, the right endpoint. But if it were decreasing, so that k is the biggest value that f double prime takes on, if it were decreasing, I would use the left endpoint, or x equals 1 as the input. So is f double prime increasing or decreasing? Folks, if I want to know if a function is increasing or decreasing, I take its derivative. So we actually need to consider f triple prime so that we understand what's going on with f double prime. I'm not going to send you off to do that. I'm going to rewrite f double prime of x by distributing in the numerator and then splitting up the two fractions. We get e to the 1 over x to the 4th plus 2e to the 1 over x over x cubed. I will spare you the task of doing this. The details give us that f triple prime of x is going to use the quotient rule 2 times. Negative 1 over x squared e to the 1 over x times x to the 4th minus e to the 1 over x times 4x cubed all over x to the 8th. I thought I was going to be able to squeeze this in here, but I can't. That's the first term's derivative. For the second term, our derivative is, so we have a plus, negative 2 over x squared e to the 1 over x times x cubed minus 2 e to the 1 over x times 3x squared all divided by x to the 6th. Now this looks like a big old mess, but let's step back a moment and notice that every term in both numerators is preceded by a negative sign. Our input values are between 1 and 2 inclusive, right? So 1, 2, and everything between them. In other words, they're positive. So if my derivative, in this case the third derivative, right? If my derivative of the second derivative has a bunch of terms that are all negative, then we know that f double prime is decreasing. And what that means is f double prime of 1 is greater than f double prime of 2. F double prime of 1 is also greater than f double prime at any number between 1 and 2. Therefore, we're going to use x equals 1 for k. F double prime of 1 is then equal to, going back to this earlier thing that we saw here, looks like it's going to be 3e. That's what we're going to use as k. Now we're ready to answer the first part of this. The absolute value of e sub t is less than or equal to 3e, that's k, times 2 minus 1 the quantity cubed divided by 12 times 10 squared. That's approximately 0.00680. That is the maximum error for the trapezoid rule. The error for the midpoint rule in absolute value is less than or equal to 3e times the quantity of 2 minus 1 cubed divided by 24 times 10 squared, and that's approximated by 0.00340. And as you can see, it's exactly half of the error for the trapezoid rule. That's because of the 24 versus the 12. Everything else is the same. For the next bit, we're turning it around. We're saying, I know I want the error to be within 1/10,000th for the trapezoidal rule or the midpoint rule. How many subintervals do I need? What n will make sure that I have the correct error? We go back to our formulas. E sub t in absolute value is less than or equal to k times the quantity of b minus a cubed over 12n squared. We already have that k is 3e for our interval. B minus a is 1. So over 12n squared is less than 0.0001. Isolating n in this inequality is going to give us that n is greater than the square root of 3e times 10,000 divided by 12, and that's approximately 82.4. Now, we might think round down, it's 82.4. The answer is 82. No, we need n to be greater than 82.4. We want to guarantee that we have the desired accuracy. So for e sub t, we'd say that n is equal to 83. We need 83 subintervals to be accurate to within 1/10,000th. The absolute value of e sub m is much the same, right? It's less than or equal to k times the quantity of b minus a cubed over 24 n squared. And so that means, look, the only thing that's changing is the 12 is becoming a 24, right? So n is greater than the square root of 3e times 10,000 divided by 24. That's approximately 58.3, and so we'd say that n is equal to 59. And so for the same desired accuracy, the midpoint rule requires us only to have an n of 59, whereas the trapezoidal rule requires us to have an n of 83.